Absolutely, there is life elsewhere and almost certainly intelligent life. It has to be. The odds are just overwhelming. Voyager 1 has been our silent ambassador to the stars for decades, and now the stars have responded. According to Bill Nye, the Voyager missions were a testament to human curiosity and ingenuity, pushing the limits of our exploration and understanding. For over 4 decades, the spacecraft had faithfully sent data back to Earth, exploring the outer planets and venturing into interstellar space. Yet their mission had always been a one-way street, a broadcast from us to the universe. That is, until now. A response has been received by Voyager 1, a sophisticated, purposeful message from the unknown. What could it mean? Is this an ordinary cosmic noise or random fluctuation, or is it a reply or something beyond human understanding? Join us as we explore how Voyager 1 just received a disturbing reply in deep space. Launched in 1977 alongside its twin, Voyager 2, these probes were humanity's first interstellar messengers, carrying the golden record, a time capsule intended to communicate the story of our world to extraterrestrials. Now, Voyager 1 has pierced the veil of the cosmos, and the universe has answered back. As Bill Nye says, humanity is on the brink of a revelation that could alter the course of history. Ever since humans acknowledged the enormity of the universe, we have intuited that life must exist somewhere, either in our galaxy or some galaxy far, far away. Given that the universe has billions of galaxies, each containing billions of stars, and that a small fraction of those stars include planets comparable to Earth, it is reasonable to assume that there exist hundreds, if not thousands, of extraterrestrial civilizations. Even more liberal was Carl Sagan, a prominent figure in the SETI movement until his death in 1996, who proposed the possibility of 1 million civilizations in the galaxy. That's a lot of extraterrestrials. It is easy to see why astronomers in the 1960s were so hopeful as they set out on their never-ending search for extraterrestrial life. Researchers from SETI embarked on a quest to discover extraterrestrial intelligence after estimating the number of communicative civilizations in our galaxy. 2 primary choices were available to them: communicating in person or over long distances. For the first one to work, either aliens or humans would have to go to the other side of the universe. Given the vast distances between our solar system and other Milky Way stars, this appeared extremely implausible. Radio transmissions, which include the transmission and reception of electromagnetic signals via space, were a part of the second scenario. A 210-byte message was purposefully delivered from Puerto Rico's Arecibo Observatory to the globular star cluster M13 in 1974 by astronomers who hoped to signal a civilization there. Data like the molecular formula of DNA and the atomic numbers of important elements were included in the message, which contained basic information about ourselves and our place in the cosmos. However, there hasn't been much of this kind of proactive dialogue. The majority of astronomers' communication strategy is based on passive listening for broadcasts sent by extraterrestrial civilizations. For these kinds of listening tests, a radio telescope is ideal since it can pick up energy waves that are too long for optical telescopes to see. Radio astronomy involves directing a massive antenna toward a nearby star that resembles the Sun and adjusting its frequency to focus on the microwave part of the electromagnetic spectrum. Due to its lower noise floor, the microwave frequency band, which spans 1000 to 3000 MHz, is perfect for this application. Additionally, it has an emission line at 1420 MHz, which scientists have identified as a hiss that echoes throughout the galaxy. Neutral hydrogen undergoes energy changes along this narrow line. Hydrogen is a perfect identifier because all cosmic civilizations should be aware of it as a primal element of the universe. Since 1960, a number of international teams have been methodically surveying the Milky Way and other galaxies for stellar signals. As we continue to explore the planets beyond our solar system, the Voyager 1 spacecraft has played an essential role that no one could have foreseen 47 years ago. Even after all this time, the probe is still sending data about its travels back to Earth, so it must be doing something right. The communication from Voyager ushers in an uncertain but potentially rewarding future. The Voyager missions took advantage of a special alignment of the outer planets that happens just once every 176 years. This alignment allows spacecraft to gravitationally slingshot from one planet to the next, making the most efficient use of their limited fuel. Spacecraft from NASA were initially intended to travel beyond Pluto, Saturn, and Jupiter, while other probes were to travel past Uranus and Neptune. Even though NASA had to cut back on its intentions because of budget constraints, the two Voyager spacecraft it launched were nevertheless quite useful. As Voyager 2 soared beyond Jupiter and Saturn, it also passed Uranus and Neptune, whereas Voyager 1 was laser-focused on those two planets. 2 golden records were approved to be installed on board the Voyagers by NASA, who recognized that the spacecraft would eventually go to interstellar space. Sounds ranging from whale calls to the music of Chuck Berry were placed on board, as well as spoken greetings in 55 languages, in case aliens ever happened upon the spacecraft and were curious about their origins. The 12-inch wide gold-plated copper discs also had schematics illustrating how to operate them and the Sun's location relative to nearby pulsars, a sort of neutron star. A trio of radioisotope thermoelectric generators, which transform the thermal energy emitted by plutonium's radioactive disintegration into usable electricity, powers the two spacecraft. A magnetometer, a 2-camera imaging system, various spectrometers, and equipment to detect low-energy charged particles and high-energy cosmic rays were among the 10 scientific instruments attached to the probes. There have been a total of 11 scientific investigations conducted aboard each Voyager by using the communication system to learn more about the planets and moons. On September 5, 1977, during launch, the Voyager 1 spacecraft almost never lifted off because the rocket almost ran out of fuel. Nevertheless, the probe swiftly surpassed its identical twin and departed from the primary asteroid belt spanning Jupiter and Mars. Prior to Voyager 2's ability to re-establish contact at a distance of 165 million miles from Earth, the Voyager 1 spacecraft transmitted its initial images of Jupiter to Earth in April 1978. In March 1979, Voyager 1 surprised NASA by detecting a tiny ring encircling the massive planet. The Ananke, 2 other moons, were also discovered. The large Galilean moons of Jupiter Io, Europa, Ganymede, and Callisto and Amalthea were also captured in great detail by Voyager 1. In the same vein as its predecessor, the Pioneer spacecraft, Voyager 2 found that the moons of Jupiter were dynamic, independent worlds. Intriguing new information regarding these naturally occurring satellites was also uncovered by Voyager 1. As an example, the fact that Io is modeled with yellow, brown, and orange and has numerous volcanoes demonstrates that moons similar to planets can have dynamic interiors. In addition, images of Europa returned by Voyager 1 revealed a mostly flat surface, with lines running across it, suggesting the presence of ice and possibly an ocean beneath it. A large subterranean ocean of liquid water, possibly capable of supporting life similar to that on Earth, is probably harbored by Europa, according to subsequent observations and analyses. On March 5, 1979, Voyager 1 approached Jupiter within 174,000 miles, passing near the tumultuous cloud tops. The probe's next target was Saturn. The only year that scientists had to wait to capture close-up images of Saturn was 1980. Surprisingly, the ringed planet was just as full of surprises as Jupiter. One of Voyager 1's targets was the F-ring, a thin structure discovered only the year previously by NASA's Pioneer 11 probe. Voyager's high-resolution camera spotted 2 new moons, Prometheus and Pandora, whose orbits keep the icy material in the F-ring in a defined orbit. It also discovered Atlas in a new ring, the G-ring, and took images of several other Saturn moons. Voyager 1's primary mission came to a close with the Saturn encounter. Following that, attention turned to keeping tabs on the spacecraft as it raced toward interstellar space. Weighing 1,590 pounds, Voyager 1 captured one of the most famous images in spaceflight history 20 years before it achieved that feat on February 14, 1990. The probe turned back toward Earth and snapped an image of its home planet from 3.7 billion miles away. The photo shows Earth as a tiny dot suspended in a ray of sunlight. The pale blue dot photograph stands out among the hundreds of other images taken that day by Voyager 1, which included the Sun, 5 other planets, and a multi-image solar system family portrait. This serves as a constant reminder that Earth is a tiny dot in an infinitely huge and unfathomably massive universe. In August 2012, Voyager 1 sprung loose into interstellar space, leaving behind the heliosphere, the enormous bubble of charged particles that the Sun blows around itself. The results came to light after a powerful solar eruption was recorded by Voyager 1's plasma wave instrument between April 9 and May 22, 2013. The eruption caused electrons near Voyager 1 to vibrate. From the oscillations, researchers discovered that Voyager 1's surroundings had a higher density than what is found just inside the heliosphere. It seems contradictory that electron density is higher in interstellar space than it is in the Sun's neighborhood. However, researchers explain that at the edge of the heliosphere, the electron density is dramatically low compared with locations near Earth. After retracing their steps through Voyager 1's records, scientists finally settled on August 25, 2012, as the date Voyager 1 broke loose from the heliosphere. Meanwhile, Voyager 2 achieved this milestone on November 5, 2018. Voyager 1 is speeding away from the Sun at a rate of approximately 330 million miles annually, while Voyager 2 trails behind at 295 million miles annually. Both spacecraft are currently investigating the boundary region, where the Sun's magnetic field interacts with the interstellar magnetic field. But that's not all, they are also probing the interstellar medium, the mysterious substance that fills the space between the stars. These investigations provide scientists with a first-hand look at the exotic environment beyond our solar system. These were the voyages of the Voyagers, 2 space probes on a mission to explore strange new worlds, to seek out new life and new civilizations, and to boldly go where no one had gone before. Just when we thought we had reached the limits of our cosmic reach, Voyager 1 sent us a mysterious message from the unknown. The message, detected by the Deep Space Network, was unlike anything we had ever encountered before. It was a series of coded signals that seemed to defy the laws of physics and logic. The signals appeared to come from a point beyond our galaxy, somewhere in the vast expanse of the universe. They contained patterns and structures that suggested intelligence and complexity. At first, scientists were baffled by the message. They tried to decode it using various methods and algorithms, but nothing seemed to work. The signals were too alien, too different from anything we had ever seen before. Some speculated that it was a hoax or a glitch, while others feared it was a warning or a threat. But then, after months of painstaking analysis, a breakthrough came. A team of linguists and mathematicians discovered a key to unlocking the message. They found that the signals were based on a universal language of mathematics and geometry, using prime numbers, fractals, and symmetries. By applying this key, they were able to translate the message into a readable form. What they found was astonishing. The message was a greeting from an advanced civilization that called itself the Suthrians. They claimed to be millions of years older than us and to have explored much of the cosmos. They said they had been watching us for a long time and had decided to make contact with us through Voyager 1. They also said they had sent a gift with the message, a piece of their technology that could revolutionize our understanding of the universe. The gift was encoded in the signals as well, in the form of a blueprint for a device that could manipulate space and time. The message ended with an invitation to join them in a grand alliance of starfaring races, to share knowledge and wisdom and to explore the wonders of creation together. The revelation stunned the world. It sparked a wave of excitement, curiosity, and hope among people of all backgrounds and beliefs. It also raised many questions and challenges for humanity. How should we respond to the Suthrians? How should we build and use their device? What are the implications and risks of contacting an alien civilization? These are some of the questions that we face as we stand on the brink of a new era of discovery and adventure. The Voyager 1 message is a testament to our quest for knowledge and our connection to the universe. As Bill Nye says, we are made of star stuff. We are a way for the cosmos to know itself.